us a little bit about your career and about your philosophy on, on your work? Just give us the 3,000-foot view of Jack Horner.
Well, I don't know. My career is spotty.
Yeah.
So, I was born and raised in Montana.
Yeah.
Went to college in Montana, flunked out. While I was at the University of Montana in Missoula, I learned a lot of geology. I learned a lot of biology, paleontology, and I learned how to, work kind of a museum. Learned how to work in a museum and how to prepare fossils for exhibit and things like that. And so my first job, I was hired to be a technician at Princeton University. Started finding looking through the Eastern museums for dinosaurs that had been found in Montana, and started my research sort of on Montana dinosaurs. And in 1977, I found a dinosaur egg. It was really cool. I didn't know what it was when I found it. I thought it was a crushed fossil turtle.
Really?
But turned out to be an egg. And then a year later, stumbled into a rock shop where a rock shop owner had some little baby dinosaur bones, and I identified them for her, and she gave them to us, and we went to the site and excavated them. It was the first nest of baby dinosaurs found in the world, and provided evidence that dinosaurs cared for their young. In 1988, I published a book called Digging Dinosaurs, and it was about the story of finding the baby dinosaurs and dinosaur behavior and things like that. And Michael Crichton picked that book up and used my character to make his Ellen Grant character, and Jurassic Park grew out of that. And I continued working, left Princeton, came to Montana State University, where I spent 34 years as the curator and a professor. And then when I was 70, I retired, thought I'd stay retired. And I was invited to give a talk at Chapman University in Southern California. So I went down there and gave a talk entitled How to Make a Glow-in-the-Dark Pink Unicorn. And after my talk, some old guy came up and said, "What can I do to talk you into teaching at our university?" And I said, "I can't live in Southern California."
Yeah.
And he said, "Well, I'll pay you a lot of money and give you a house to live in, and you can teach as long as you want."
And I said, he talked you into it?
And I said, "Thanks, I'll take it." Yes.
Early in your career, when you were first getting, I can't remember if when we had talked earlier, you had said that this was as a graduate student or when you were beginning your career, your work in museums. Somebody had told you, "Hey, look, we're about mammals here. We know everything that there is to know about dinosaurs."
Well,
what was your reaction to that?
Well, it was at the University of Montana when I first went there. I wanted to become a paleontologist, and even though I, had basically flunked every grade getting to college, but yeah, I went there. They had a really good geology department and a good paleontology program. And I told them I went there and wanted to study dinosaurs. And they said, "We know everything there is to know about dinosaurs. They were just, these big, ugly green lizards that went extinct. We study mammals here."
Is that line of thinking just totally unbelievable to you? That like somebody would have had it, or is it like sadly believable that somebody would have thought that?
Well, the thing is that at that time, people really just, and I have to admit, up until maybe 64, 65, dinosaurs had been pretty much treated as just, showy things in museums. And
they were more
people
spectacle than science.
Right. Yeah. And so no one really studied them. They didn't really know very much about them other than the fact that they were reptiles. And at the time, everybody thought they knew what reptiles were like, right? I mean, they abandoned their babies and they're just not interesting animals. And in 1964, a guy named John Ostrom at Yale University found a dinosaur in Montana that he named Deinonychus, terrible claw. And, it's Velociraptor, basically.
Yeah.
And from that, he was able to take that skeleton and compare it to the early birds like Archaeopteryx and determined that he really, it wasn't the first time somebody had suggested it, but he had pretty good evidence that birds were the descendants of dinosaurs. And that was the first time. I mean, people all of a sudden realized that dinosaurs were probably, if they gave rise to birds, were, more bird-like than typical reptile-like. So when the babies were found and there was evidence of parental care, much like birds, that really helped the whole
solidify.
Story. Right. And so that was, some people refer to it as the dinosaur renaissance, when the whole idea of dinosaur went from being, boring animals that were just looking for a place to go extinct to, the ancestors of birds. Yeah. And the fact that birds were actually a group of dinosaurs, and that we now, we separate them into avian dinosaurs, which are birds, and non-avian dinosaurs, which are the ones that went extinct.
Yeah. So I'm going to ask you a question that's, I'm sure I'm going to be ridiculed online for it being a fucking stupid question. Birds are the descendants of dinosaurs. Does that mean, like, what the fuck's an iguana? Like, what's that a descendant of? I mean, is it also like a descendant of?
Iguana is a lizard.
Yeah.
It's a reptile.
Yeah.
A bird is a dinosaur and therefore a reptile.
Okay. So it's just two different branches.
Birds are reptiles. This is the hardest thing for most people to.
Okay, perfect. That makes me feel better about that question.
and I'll give you a little history on it, so that because it just really confuses older people.
Okay.
Because we still learn in school. In most schools, we still learn that there's fish, amphibians, reptiles, birds, and mammals. Right? We learn that there's 5 distinct groups of vertebrate animals. And this way of thinking says that birds are actually reptiles, that they're in the same group, right?
Yeah.
And it's just sort of shakes people's foundation, right?
It's weird to think about.
But if you think about where that idea actually originated, it comes from the 1700s. Back in the days before anyone knew anything had gone extinct or evolved. And so back in the 1700s, 1750, when Carl Linnaeus was coming up with these groups of organisms, his foundation was basically creationism, right? At that time, people thought that these 5 groups of vertebrates had been put on Earth in a couple of days.
5,000 years ago,
right?
Yeah.
And so that they were distinct creatures and you could easily identify them.
Right.
But after 1800, when George Cuvier presented the theory of extinction, that animals had actually lived a long time ago and are extinct now, people started collecting some of these extinct organisms and trying to put them into these classifications and realizing that birds have ancestors, and even dinosaurs have ancestors, and crocodiles have ancestors, and iguanas have ancestors. You start going back in time and looking at these ancestral lines, and you realize they start merging together, right? Mm-hmm. And then So Cuvier comes up with, the origin of, the idea of extinction, and then 59 years later, Darwin comes out with the origin of species, right? So then sort of ties this whole thing together, and now we know, that there's all these common ancestors of all these different groups of organisms, but we still don't teach that in school.
No, we just kind of stick to this archaic.
We still stick to the 1700s idea in most schools.
Just based on surface level observation.
Exactly. Yeah. And so, kids get to college now and we have to re-educate them.
Yeah. It's super interesting. I'm glad that wasn't such a stupid question.
That was not, no.
Well, and that's super interesting because you have a project affectionately referred to as like Dino Chicken or
Yep.
Chickensaurus.
I do.
Can you tell me about it?
Sure. Yeah. Well, when I was working on Jurassic Park,
well, sorry, I got. That's the other thing that's hilarious to me is like the whole premise of Jurassic Park in relation to Dino Chicken. It cracks me up, man.
Well, it all ties together. I was working on Jurassic Park. I was on set. I was, these giant puppets like the T-Rex were run by 20 puppeteers, and the dinosaur was like real. And I was thinking, wow, it'd be, dinosaurs are really cool.
Yeah.
And then I got to thinking about Michael Crichton's idea, the idea of getting DNA, from a dinosaur. And
again, Michael Crichton's the author of Jurassic Park. So
yeah.
the fictional idea that you might...
The fictional idea sounded sort of interesting. And at that time in 1990, right around 1990, 91, we were all sort of thinking about things like that and interested in seeing if we could get DNA from something, from a dinosaur. And the idea of getting it from amber, from an insect that might have, bitten a dinosaur, it was plausible. I mean, it was a plausible
cool idea.
And so, but, even back then we realized that amber actually breathes. I mean,
does it?
Yeah. And so it doesn't breathe like us.
Right.
I mean, it's
porous on some level.
It's porous. Yeah. And so, people tried to get DNA and I've said it many times, if you actually could get DNA out of something in amber and clone it, you'd probably get a whole bunch of mosquitoes, right?
Oh.
Or, trees.
Yeah.
I mean, whatever. But dinosaurs.
The last thing you would get.
Right. Yeah. So, but it's an interesting idea. And so in 1993, one of my students, Mary Schweitzer, she and I actually submitted a grant proposal to try to extract DNA from a dinosaur, a T-Rex that we had excavated in 1990. And we weren't able to find DNA. We weren't able to find any evidence of it. But Mary ended up finding, soft tissues and
how does that stay?
Well, that's one of these, preconceived ideas that things can't preserve.
Yeah.
Mostly because people didn't look before.
Oh.
So, but, chemistry is chemistry, and molecules of basically, whether you're looking at molecules of wood or molecules of whatever, there's nothing to say that they can't hang together if something doesn't destroy them. When an animal dies, it begins deteriorating because of bacteria, right? Bacteria starts consuming a dead animal. If the bacteria can't get to a particular area, like deep inside of a bone,
sure,
then it's possible that those molecules will just stay intact. And that's what it appears has happened. So Mary was able to find blood vessels and and bits and pieces of proteins, and I mean, a lot of cool stuff.
How come the proteins will stay intact, but the DNA will not?
Well, DNA is a huge molecule.
Okay.
It's an enormous molecule. The cell that it's in the nucleus of a cell keeps it together. And
Okay.
as soon as the cell dies, all of the machinery holding it together are gone, and the molecule just starts falling to pieces.
So it's just
It's not a stable molecule, whereas a protein like collagen is much more stable.
yeah. So it's just like when you pull away the scaffolding from the complex structure, it falls down.
Falls down.
But if all you have is a rock or the cinder block, the cinder block will stay in place pretty indefinitely.
Exactly.
Gotcha.
And so, there's a mammoth elephant that was found that's like 8,000 years old. And they have, the DNA has already deteriorated quite a bit, but there's still, they think, enough there that they might be able to add a little modern elephant to and come up with something that's kind of like a mammoth elephant.
Huh.
Dinosaurs, on the other hand, went extinct 66 million years ago.
Yeah, you're not going to find that
And
DNA.
there's just nothing left. I mean, it just has come apart completely. There may be, tiny pieces that are still stuck together.
Yeah.
And we may, as our equipment to locate this kind of stuff gets better and better, we might find tiny, tiny pieces, but we don't have, birds are dinosaurs' descendants, but there's so much evolutionary history
that it's
after dinosaurs till modern birds that it just. So the Dino Chicken Project, the whole idea really was to see if since we couldn't find DNA and birds are dinosaur descendants, I thought it might be possible to find some what we call atavistic genes. And atavistic genes are genes that basically characterize something in an organism, but they've been shut down during the course of evolution. In other words, they've been turned off. They're genes that were useful at one time and now are not, and so they've been turned off. But atavistic genes occasionally accidentally turn on in some organisms, like little kids, babies sometimes are born with some extra vertebrae in their tail.
Okay.
And the doctor just cuts it off. I mean, they're just, but our ancestors had a tail, right?
Yeah.
Every once in a while, snakes are born with legs because their ancestors had legs.
So it's a vestigial trait.
It's
pretty
a vestigial trait
popping up by chance.
that accidentally, one of these genes just turns on accidentally. Yeah. So I was hoping that we could find atavistic genes in birds that characterize particular features of dinosaurs, of the non-avian dinosaurs. And so I built a laboratory to do that, to see if we could find these atavistic genes. And we didn't find any of them in our lab. But when I first made the lab, people thought I was just absolutely off my rocker. I mean, they thought I was
some
crazy.
mad scientist.
Yeah. And people said, it was a death knell for anybody that worked on the project. It was just a stupid idea. But 2 years after we started working on it, Yale University,
said, this is kind of interesting.
Yeah, they thought that was interesting. And so they started working on the project. And then when Yale started working on it, then Montana State said, well, I guess it's okay. So Jack can, have a lab. Our first lab was in the back of an 18-wheeler trailer sitting next to the Museum of the Rockies.
Really?
Yep.
That's awesome.
Just a state-of-the-art laboratory in a 18-wheeler trailer.
Did you ever move it anywhere else?
Well, we moved into a building on campus.
Well, I'm asking, did you take that lab and use it for any sort of field stuff?
Oh, yeah. Well, it was originally made for, it was originally built by Mary and I to try to do DNA extractions. We thought maybe the DNA was breaking down when it hit the atmosphere.
Mm-hmm.
And so we figured if we took the laboratory to the field, right to a skeleton that we had just excavated, that we might be able to do
tap it out real quick.
Might be able to see it, but it didn't work. The
Sure.
proteins were better. I mean, a lot of things were better.
Yeah.
But we didn't find DNA. So we retrofitted that laboratory into the Dino Chicken laboratory. Yeah.
Okay.
Yeah. And so you started, I hired a couple of people and we started working on it. And between everyone else's lab in the world that started also kind of fiddling around with that sort of stuff, we now, theoretically, we could make an animal that would have a head more like a dinosaur and have hands and arms rather than wings and a long tail.
Yeah. So basically
It looked more like a velociraptor. Yeah.
Oh, that's wild.
I mean, we could do that, but in the last 10 years between the time I said, let's try to do it.
Yeah.
And now it has become so controversial. I mean, there are people that say you're playing God. There's, you shouldn't do it. Oh, did you see Jurassic Park? I mean, all kinds of, and
how many times do you get that quoted to you though?
Oh,
you were so worried about if you could,
exactly.
You didn't figure out.
I look on my phone right now. I probably got 10 of them.
Yeah. Like the irony of that's awesome.
Right. So it's just, so I posted, I think in social media somewhere that, we basically have gotten to the point where all that's left now is to actually do it. But we need a generous, intrepid donor and an island.
Yeah. So basically the whole premise of the Dino Chicken process is that rather than having it be an additive route to building a dinosaur, like you take the DNA and you do the stuff and you grow it into a dino, you're taking a more reductive route, taking something that evolved from the dinosaurs and walking it back until you get to the, that's so cool, man. That's so cool.
Yeah, I think we could, but
well, what about George Lucas, man? Where's he at?
Well, he put up the first million, so. Yeah. So, but it's not even a matter of money right now because it has become so controversial that we couldn't really do it in any institution that gets government money. Right. I mean, so you'd have to do it in a private lab.
Yeah.
That's why I say an island because
what do you think of the controversy there? I mean, do you
well, it's just, I think science is one of those things I think we should know. I think we should do everything that we can do. And, obviously there are things we don't want to do. I mean, but on the other hand, if we say, okay, you can't do this and you can't do that, some other country's going to do all of this stuff and we're going to be left in the dust. Right.
Yeah.
And in some cases it could be really detrimental to us because if we say, well, we shouldn't mess around with these potential, chemical warfare or germ warfare, anything like that, but somebody else is messing around with it, then we have to be able to defend ourselves somehow, right? So we should know everything.
Yeah.
That doesn't mean we have to do everything. It just, science should not be limited. I don't think, but that's probably really controversial.
Yeah. I mean, when I think about something like that, like something that I can make a proxy to is kind of originally Everest, right? And we just done a podcast. We recorded a podcast with Tom Pollard, an Everest historian, yesterday. There are some folks that believe you ought not to climb Everest because of these spiritual things that surround it. And it seems like this idea in regard to your project is almost adjacent to that. And whether people want to be like it's ethics or spirituality, like really at the end of the day, what all those people are concerned about is they get some sort of undiagnosable heebie-jeebie about it.
Right.
And so they kind of say, oh, that freaks me out too much to co-sign. And you think that that's kind of like an archaic sort of view of it. Because also like, you know, in using that Everest example, you know, I'm not trying to talk down, like, I guess, indigenous beliefs about that stuff or the beliefs of the Sherpa folks or all that. But
yeah, no, I just, like I said, I think we should learn everything we can and figure out as much as we can. I just don't think there should be any limitations on science. Yeah.
Not even in like, what do you think about like the CRISPR gene editing stuff?
I think it's really cool.
I kind of think it's
cool
ready
to get right with it and do that. Yeah. Make new kinds of animals. You know, if you think about the animals we have, right? You think about lions or tigers and panda bears and rhinoceroses. We have all these animals we really love, but they're going extinct because they're in the wrong habitats, right? I mean, panda bears especially.
Sure.
And so we've got a whole bunch of animals we love, but we can't take care of, mostly because they're in somebody else's backyard, right? Mm-hmm. Then we have a whole bunch of animals like skunks and possums and raccoons that have adapted well to live with us, and we don't like them, and we call them vermin. We go out and shoot them, right? And so we've got animals we love, we can't take care of. We got animals that love us, and we shoot them. And the animals that we love the most are our domesticated animals that are genetic modified organisms, GMOs, all of them. Everything we eat and all of our pets and basically everything we farm, right? Yeah. They're all GMOs.
Yeah, a cow is not an animal.
Why not make more?
Yeah.
I mean, think of a chihuahua. I mean, if you can make a chihuahua, why can't you make a dino chicken?
Yeah. I'm with you.
Yeah.
And it's almost like interesting when you consider like, I don't know, evolution. And then I was listening to two people much smarter than me having a conversation about this the other day. So I might bastardize it. One of which is co-producer and engineer Andrew O'Neill. And the other one is my buddy, Drew Smith, who he's a dentist and just a really curious outdoorsman. He lives a couple doors down. But they were talking about epigenetics and the idea that there are, you know, some traits that are born of, you know, just like environmental factors. That's I'm getting that right, Andrew? Okay. And it's almost like at a certain point, you'd almost consider human intervention, you know, some level of like epigenetic evolution, right? Like
I don't have any problem with it at all. Yeah. I mean, if people want their kids to have brown eyes or blue eyes, or, you know, why not?
Yeah. No.
I just don't have any problem with that at all. I mean, we are learning so much.
Well, it's a tool.
It is a tool.
Like how different is it than the wheel or the hatchet or, you know?
Yeah. I mean,
it's an advanced tool. Yeah. It's complicated.
Well, we're certainly working in AI very fast, aren't we? So, you know, but I just don't have any problem with it at all. But there are a lot of people that really do.
Sure. Do you think you'll ever have a little dino chicken running around?
Well, I think we could.
Yeah.
But, you know,
do you think do you think in your lifetime,
if somebody's going to give me an island, yes, I could.
we got to talk to somebody, man. I don't know who that would be. We got to talk. You know who I bet you would do it? Joe Rogan. Joe Rogan, if you ever hear this, man, we got an investment opportunity.
You know, there's just so many things we could do, but again, you know, we come up against a lot of, you know, politics, religion. I mean, there's just all sorts of things in the way, right?
Sure.
And, you know, people have different ideas of what, you know, ethics, right? I mean, what is ethical?
Yeah.
And at Chapman, these are the kind of things that I talk about with my students, and you know, they're pretty much up in arms over a lot of this stuff. I mean, you shouldn't be doing that. You shouldn't do this, and you shouldn't do that. And then I'm like, well, why?
Or are they worried about
Well, dinosaurs are, they watch Jurassic Park, so they really think dinosaurs would be like that, right?
Yeah.
And we all know that dinosaurs are like any other animal. And if you go on a safari and keep your windows rolled up, you're not going to get eaten, right?
Yeah.
But after you see Jurassic Park, you think these velociraptors can break into your car and,
they'll crack the code for the keypad.
They'll figure it out. All right. So, so people are afraid of dinosaurs because of the movies, not because of
you were
reality.
You were a technical advisor on those movies. Was there ever a point where you were like, "Hey, man, that fucking dinosaur wouldn't do that"?
I said that all the time, but it's a fictional film.
Yeah.
And the idea is that it's entertaining, and I wanted to be entertained too. I mean, I like a good fictional movie.
Yeah.
And so, my job really was to make sure they looked as good as they could for what we knew at the time and what would work technically at the time. So we knew that velociraptors should have feathers in 93, but there is no way
CGI wouldn't.
The CGI, it was, brand new at the time.
Sure.
And the big life-size puppets would look stupid with feathers stuck in them.
Sure.
Big, feathers stuck in the rubber.
Just not that much finesse.
Wouldn't have worked at all.
Yeah.
The new movies that are coming out now, the new Jurassic Park Jurassic World that they're working on right now, will have feathered dinosaurs in it. So I don't know. I'm not working on it. I've passed the baton. 6 was enough for me.
Yeah.
But
so when they're finally getting dinosaurs to where you want it to look like, you're like, okay, that's enough. I'm just happy that you're doing it.
Yeah.
Does it make you grit your teeth at all? How that has impacted the public perception of how dinosaurs might be?
Well, not really. No. I mean, before Jurassic Park, I had 3 or 4 students. They were all guys. After Jurassic Park came out, I was just inundated with requests, and there was 50-50 male female.
That's amazing.
The Laura Dern character, a female paleontologist, helped out a lot, and so
it's funny. There's a really interesting parallel at Penn State to this. There was a professor, Joe Humphreys, and he was the wrestling coach, but he also kind of taught this fly fishing class at Penn State. So Pennsylvania, there's a whole bunch of really awesome spring creeks. And when River Runs Through It came out, his class went from being something that you could get into and it was popular among the campus. Oh, you should take this, is really interesting, to dude, you got into that class, it became this kind of phenomenon. So it's kind of interesting to see that parallel. Other than the velociraptors, right? The main antagonist in that, aside from, I guess, the eccentric dinosaur building, I forget what that character's name is. Who the guy who looks like Colonel Sanders is all dressed up white. Yeah. Aside from Hammond, yeah, sure. Aside from him, the antagonist is the Tyrannosaurus Rex. Why is everybody so twisted about your thoughts on the Tyrannosaurus Rex being a scavenger?
I don't know. Who knows? Everybody, it's Tyrant Lizard King is its name. So
I was looking at Reddit, and people are losing their minds, or have been losing their minds for a period of time now.
A long time.
That you even dare posit that the T-Rex is like a scavenger.
Yep.
Why?
They want to, killers are
cooler.
Are cooler, right?
Yeah.
And, it's ironic because, a lot of people do hunt.
Yeah.
But most of us go to the grocery store, right?
Yeah.
So we are scavengers, right?
Huh. I have never thought about that way. I have never thought about it that way. That blew.
But, I mean, you know that, if you're a cheetah, you definitely have to be a hunter, right? I mean, you've got a high metabolism. You've got to catch something that has a high metabolism itself to give you, the protein and everything you need for your body to keep it going strong, right? You're not going to go out and catch turtles.
Right.
You're not going to eat turtles. But a Tyrannosaurus Rex is a huge animal, and the bigger you get, the less agile you are. I mean, and a T-Rex, as it gets bigger, its teeth get rounder. I mean, they become bone-crushing things.
Yeah.
I get hate mail from sixth graders. I mean, they can't stand the idea that T-Rex isn't, an apex predator. And yet, if you think about it, killing another animal, it'd be just like us killing an animal with our bare hands, right? If we didn't have a weapon, it's dangerous. And there's a good chance that you're going to end up dead. And so, scavengers have it pretty easy. You just let somebody else do it. And then and if you're big enough, you chase them away.
Well, it's like how all the time you see, wolves getting chased off kills by grizzly bears.
Exactly.
And that's not to say that grizzly bears don't pick something off, because I mean, they certainly do. In fact, there's a dude, Wes Larson, who we've talked a couple times. He just filmed this really awesome video in Yellowstone of this moose hauls ass by him. And then 2 seconds later, there's a grizzly bear hauling ass behind the moose, trying to get after him. But, I've never.
But a bear doesn't, a wolf is going to catch an animal a lot easier than a bear is.
Sure. And a velociraptor is going to catch stuff a lot easier than a tyrant. What about bigger, less agile dinosaurs? Like a brontosaurus, right? Would a T-Rex? Well,
first off, they didn't live together, so we don't have to worry about that. But size is an advantage, right? So I actually think that the velociraptor-like animals could scale their prey.
Yeah.
They have recurved claws like a cat.
Yeah.
Everybody can't do the same thing, right? I mean, you have different trophic levels, you have different ways of getting food.
Yeah.
And if you go to the Serengeti, you've got cheetahs, you've got you've got leopards, you've got lions, you've got all kinds of animals that do chase down their prey. But look how many hyenas there are.
Sure.
That are total opportunists, right? I mean, they'll go after the sick. They will hunt a little bit, but mostly they just chase away somebody else.
Yeah.
And they have bone crushing teeth. They can eat a carcass that's even been fed on by something else. I mean, and condors, look how big they are. I mean, they're scavengers.
Yeah.
So, but the idea that T-Rex is a apex predator, I mean, that everybody wants them to be the top of the food chain.
Yeah, and everybody wants a bald eagle to be like,
exactly.
And it's just, Benjamin Franklin posited it's just not.
That's right.
So again, I guess this is probably me being part of the Jurassic Park generation, because I was born in 1991. So I mean, I hit that just perfect.
Yes.
I was that generation. And that's what I think part of what led me to ask about brontosaurs, which, as you've pointed out, did not exist at the time of T-Rex.
That's okay. There were some long-necked dinosaurs probably, but
was there any potential herbivore of that size or something that could have been like about an equivalent prey item in the way that you might have like a grizzly bear and a moose?
If you look at we don't have any live ones, right? Everything was dead. And so you find a carcass, except the chicken, right? When you find a carcass that's been fed on by a T-Rex, I mean, they have decimated the carcass. So, I mean, you can tell that they've been scavenging. We find bite marks in the pelvic region. I mean, which means that there can't be much meat left on it. I mean, so basically every bone in a Triceratops that has been fed on by a T-Rex looks like it's been scavenged.
Yeah.
You don't find little hardly ever do you find little bite marks of velociraptor-like animals, right?
I was going to
They're
ask.
not going to hit the bone.
Yeah.
They're going to eat the flesh.
And then they're going to get chased off.
And then they're going to get chased off, right? So it's pretty easy to see what's going on, but then we have, the preconceived ideas and the people who just want it to be the way they want it to be.
How often do you run up against that? And I guess this has been like a little bit of a theme of our conversation. People in the scientific community, or, people who are fans of the scientific community, for lack of better words, like hobbyists, who just cannot handle the idea that something that they believe to be true would be challenged or proven false. Yeah.
Well, it happens a lot.
Yeah.
I mean, we all have some preconceived ideas of something. And so, I guess that's been that's what everybody claims I do, is challenge the status quo.
Yeah.
Challenge convention.
Yeah. And what if you found some like really compelling evidence that actually, in fact, T-Rex, they would not scavenge, and all they did was hunt, and here's what they like to hunt.
Yeah, well,
would you be just as happy to find that out?
I would be, but it's just, people come and say, look, here's a duckbill dinosaur bone with a broken off piece of a T-Rex tooth in it. That's proof that they were hunters.
Could you tell me about that? Because I've heard that referenced before.
Yeah, there is a tailbone of a duckbill dinosaur that has a piece of what looks like a Tyrannosaurus Rex tooth buried in, and it continued to grow. And I'm
I see. Okay.
And I'm like, okay, well, that, obviously the first thing I always try to do is I say, okay, if this was a hunted animal, I want you to explain to me how the T-Rex would have been, how this whole thing would have, you got a duckbill dinosaur running along, you've got a T-Rex running along after it.
Yeah.
And it reaches over and bites the tail while they're running, and the duckbill dinosaur gets away, and it's just got a tooth stuck in it.
Yeah.
Okay. All right. Well, that's certainly possible, right? Yeah. But I would say that it wasn't a very efficient T-Rex.
Right. Yeah. Yeah.
Seriously, but on the other hand, if it's a sick duckbill dinosaur and it's not doing very well, and T-Rex is a scavenger and mostly a scavenger, and the duckbill gets away, and there's plenty of food around for scavengers, right? There's always sick animals, and there are always dead animals, and these other hunters are getting lots of animals. You just chase them away. And there's another scenario where it looks like where someone has suggested that some bite mark is in the top of some duckbill dinosaur, or the T-Rex was running along, reached over and took a chunk out of the top of a duckbill dinosaur. And I'm like, well, that's,
seems weird.
Seems really weird. Again, not very efficient.
What are the angles of that?
And that's right.
What context does that happen?
How do you position these animals in order
duckbill dinosaur was asleep and he just snuck up and took a bite.
Yeah. That's what I always say. How do you know he wasn't taking a nap?
Yeah. Yeah. And basically your thoughts on that T-Rex tooth being embedded in the bone and the bone having evidence of healing is just that, I guess it happened, but it's an exception rather than...
Definitely happened, but,
it's hard to take one bone and be like,
exactly.
This is conclusive evidence that this is how it was most of the time.
Exactly.
Okay.
Yes. And especially when we find so many bite marks, crushed bite marks in all these other bones. This animal is doing everything we see in a scavenging mode. Yeah,
so you're saying like, okay, there's this one instance of exception, but the mountain of evidence we have otherwise. Yeah.
Yeah. So, but again, the people that want them to be apex predator will hang on to that tooth embedded and that's all they're going to talk about. They're going to ignore everything else.
Yeah. If you don't move, will the T-Rex not see you?
Good God. The funny thing is, when we look, we have the brain case of most dinosaurs. We can CAT scan them and see how big their brain was and which parts of the brain were, the biggest. And the olfactory lobes of a T-Rex, for the sense of smell, are huge. And if we take a bloodhound and CAT scan it, what we see is they have a relatively small olfactory lobe, but they've got these huge olfactory septa in their giant nose, right? And so they can come in here and sniff the floor and tell I was here, tomorrow.
Yeah.
If you CAT scan like a turkey vulture, turkey vulture has a huge olfactory lobe and small olfactory septa, and they can smell a carcass 25 miles away.
Really?
Yeah. And so the proportion of olfactory lobe to brain in a T-Rex is very similar to that of a turkey vulture.
That's unbelievable to me.
They could smell a carcass a long ways off. And the cool thing about a carcass is it ain't going anywhere.
Yeah. That makes it pretty easy to get to. What good would a bloodhound do if it could only smell something 25 miles away? Right. And it's interesting to think about because I don't want to go on a tangent here, but I do a lot of turkey hunting. Mm-hmm. And one of the interesting things about turkeys is like you hear a quip a lot that if they could smell, nobody would ever kill one. But their eyes are so unbelievably developed and their hearing is so unbelievably developed. I'd imagine a turkey vulture, just being a raptor, would have unbelievable eyes too.
Yeah.
And then
Velociraptor
following
has
that
really
back,
good optic lobes. Yeah. So we can see.
What about a Tyrannosaurus?
No, their optic lobes are little.
Yeah.
They're small.
So they might not see you, but they'd smell you out anyway and it'd be over.
They'd definitely,
Particularly if you were already dead, because they're scavengers.
Especially.
Yeah.
I gave a lecture one time to the American Bar Association just after Jurassic Park came out, and it was entitled, "Would T-Rex Really Eat a Lawyer?" And of course, it was about T-Rex being a scavenger.
Yeah. So maybe.
Yeah.
All right. Well, hey, let's take just a little break right here. We're going to talk about a lot of cool stuff afterwards. I'm not exactly sure what about, but we'll get to it when we get to it.
Okay.
The controversy of the age classes of dinosaurs.
Ontogeny,
rather than different species. Explain the controversy there.
Yeah, well, it's really simple. If we think about humans, right?
Yeah.
There's a big difference between us when we are little, us when we are a teenager, us when we are in our 30s, us when we are in our 60s, and us when we are in our 90s. We look different in each of those stages.
Could you imagine if we had proportional size heads to what babies have?
Yeah, just imagine that.
This big-headed species.
Yeah, with big eyes, right? Yeah. So it has been hypothesized that, and I pretty well determined that at least the changes that you go through as a child, that you also see in a kitten or in a puppy, they're cute, right? We look at them and they're adorable, right?
Fosters that.
And that is a releasing mechanism that we and all other animals that care for their young have that releasing mechanism also. And we do want to care for them. And that's why some animals will literally adopt a juvenile animal that's not even the same species.
I don't what do you mean a releasing mechanism?
It's a it's a kind of a switch in our brain that
it just flips. You see this thing, you go,
we see it and we want to take care of it.
Yeah.
Right. And we have a number of switches in our brain, right? I mean, when somebody's angry, we know they're angry. I mean, there are certain features, right? Facial features that elicit different responses. So if you think about, babies through becoming an adult, they change drastically, right? I mean, and it's same for a puppy and a kitten. I mean, they're adorable for a period of time, and then when they change to, their more adult-like features, we don't like them as much anymore. We don't tend to want to bring them home, right?
Well, the Blink 182 song, Nobody Likes When You're 23, man.
And so, same with us, I mean, when our kids, finally get their adult features, it's time for them to go get a job, right?
Do you think it flips another switch that says move them out?
Well, you would think it should, but more and more,
it doesn't seem to.
Home. But so we see the same thing in dinosaurs, and dinosaurs go through basically the same. Not the same, they don't have the same features necessarily, but they have juvenile features that they lose at a particular point in time. And it's usually around, so if we're looking at a horned dinosaur, for example, a Triceratops is a good example. They hatch out of their eggs. When they're little babies and their heads are like a foot long, they have little stumpy horns and a short little shield.
Sounds adorable.
And as they grow, they develop these triangular bones along the edge of their frill, and their horns actually grow and curve backward.
Okay.
And then as they begin to develop and get older, their horns actually grow forward. And when they are forward, the animal is an adult. And those triangular bones actually flatten against the frill. So there are juvenile features and there are adult features. And what was interesting is, going back to the earlier conversation we were having, talking about how museums wanted bigger specimens. Mm-hmm. Somebody'd go out and get a big one and somebody'd want a bigger one. They never found the juveniles. And so Triceratops,
because they didn't look for them?
Triceratops was first found in the late 1800s, and it wasn't until, the late 1990s that we found the first juvenile Triceratops, because people overlooked the juveniles. They wanted big ones in their museums. So
earlier in the conversation, we related that same thing when I was like, well, is it like finding gold, right?
Mm-hmm.
People are interested in big nuggets. They don't care about the flake.
No.
Is it similar in that when they found little dinosaurs, they're like,
I don't think they found little dinosaurs.
Well, how could they find the big ones without coming across them randomly?
They probably did come across them, but first off, the skulls, just like a child, the skull bones aren't fused together in the juvenile, so they all come apart. So they're just fragmentary, laying around on the ground, and people probably didn't even notice them. My friend Mark Goodwin and I published the first ontogeny of Triceratops in the 2000s. I mean, people had not collected juvenile Triceratops. I mean, it was shocking. And then we started realizing that there were a whole bunch of dinosaurs that were like that we started looking at these ontogenies, and a lot of dinosaurs had been given wholly different names because they look so different as a juvenile or a subadult even before the adult features are complete. It's like a cassowary, right? The crested bird, the cassowary, is like 70% grown before the casque starts to grow.
Mm-hmm.
So if you found if you didn't know it was going to grow up to be a cassowary, you'd think it was a different bird.
Yeah. You'd be like, this is an adult version of whatever this is.
Exactly.
So I'm sure some people listening are maybe equating it to, I keep talking about bears. I don't know why I'm on bears today, but well, they might be like, well, I'm sure a black bear and a grizzly bear, their skeletons look pretty darn similar. And maybe in a couple 100 million years, if somebody was digging up fossils and they found a black bear and they found a grizzly bear, by, that logic, maybe they knock those two things, which we know to be distinct species, and they go, oh, well, these are actually the same one. This black bear is a small grizzly bear. But there is something that you've done with the bones.
Yeah, we look at bone histology. We just cut the bones, and then we could tell how mature they are.
Describe cutting those bones in half and describe why people shouldn't necessarily be wringing their hands when they imagine you sawing into dino bones.
Well, the first thing we do, we mold and cast the bone so that we have the morphology. Mm-hmm. And then we take out the midsection of it and cut that. We make a cast of it too, so that we can put it back and reconstruct the bone just the way it was before we start cutting. And then we take the real bone and cut it, and then we make these thin slices that we look through, and we can tell all sorts of things about, we can tell how old they were when they died, how fast they were growing, a lot about their physiology. We can tell that dinosaurs were warm-blooded, for example.
That's another... This podcast is going to be called The Controversy of Jack Horner. I don't know that, but... So, and basically what you would find is in a lot of these things that were considered, they were still grouped together just based on certain characteristics, right? Like people would be like, oh, well, this is these things are related. And these sort of...
They could tell they were related, right?
But in cutting these cross sections, you would see like the density of the bone. That was like the big giveaway, like the sponginess, kind of how kids they don't really break arms. They'll have like a green limb while they'll sprain them, kind of funny.
Yeah, well, when animals are young, they're growing faster. Uh-huh. Even a cold-blooded animal, a young cold-blooded animal a young one grows faster than an older one. So our metabolisms are higher when we're young. And that's basically true in all organisms. And so the bone histology, the bone structure is very different in a juvenile than it is, say, in a half-grown or a full-grown individual. Mm-hmm. And when an individual is full-grown, the bone is pretty dense, and there's a lot less blood vessel openings, the holes through the bone, because the metabolism is slowing down, right? And so big vessels in the young animals and smaller vessels in the bigger bones. I mean, you literally can, and in dinosaurs and in most, almost including ourselves, there are lines of arrested growth. So every year we lay down a line of some sort that when it's wintertime for like elk, elk will stop growing for a period of time and lay down a line of arrested growth. Mm. So you can cut the bone of an elk and tell exactly how old it is.
Yeah, or like the rings in a bighorn sheep.
Right, exactly. I mean, we do the same for a dinosaur, and we can tell how old it was when it died. And we can tell, even in the young individuals, we can tell a newborn, newly hatched one from a year old or a month old. I mean, we can get it. We're getting it pretty precise now because we have these ontogenies, right? Mm-hmm. Lots of individuals that we've cut so that we have a good sense of what changes are occurring as the animals grow up.
What is like the average lifespan of? I don't really know how to ask this.
We don't really know the lifespan of dinosaurs. We don't know the upper end of it because we don't know if we've ever found the oldest one, right?
Right, yeah.
I mean, it's like a humans. I mean, you think about really old humans, there are very few of them, right? Mm-hmm. Most of us humans probably now die in, late 70s, early 80s, say that, the most, that's probably, on average, I don't know if that's true or not, but I would guess that's somewhere around where most people die. But there's a lot of people, there's some people that go well into their 90s, right?
Yeah.
And a few that go past that.
Yeah.
But so with dinosaurs, with duck-billed dinosaurs, where we have lots of them, we know they hatch out of their eggs about 16 inches long. They grow to 9 feet long the first year. They're ripping along like a bird.
Uh-huh.
And then they start slowing down after that. And what's interesting is that when they reach about 4.5, 5 years old, that's when, sexual maturity probably is. And what's interesting is we start losing them in that range. And then they're full grown somewhere around 8 or 9. And then, go into senescence, basically.
Mm-hmm.
Then they're old timers right after that. And so, they really grow fast, but they don't live that long. Considering how big they are.
What would the oldest dinosaur to your knowledge be? Do you know that?
I don't even know. We've got T-Rexes that are maybe close to 30.
Really?
And some of the big sauropods, it's really hard to tell, the long neck dinosaurs, but maybe 50, maybe 60.
Yeah.
But
that's still shockingly old.
Well, think of how old us humans are.
Yeah, but I just feel like something so big. I guess there are examples of, big organisms like the Greenland shark or whatever that live but normally when you hear about really old things,
they usually have low metabolism,
right?
Like turtles. And
exactly.
Live over 100. But like I say, with sauropods, it's pretty controversial.
Yeah.
Because we have a really hard time. Their bone structure is very different than most of the other dinosaurs.
Uh-huh.
And the bone gets reworked, and so it's hard to tell exactly how old they are.
Yeah. Attentive listeners will have noticed that a couple minutes ago, you were talking about dinosaurs being warm-blooded.
Yes.
I'd love to hear more about that.
Well, first off, birds are warm-blooded, and birds are their descendants. So people used to say, we can characterize birds because they have their hollow bones, they have feathers. There's certain things, certain features about them that are characteristically bird, right?
Yeah.
Well, we know all of those characteristics now. Actually, dinosaurs had first. Dinosaurs had hollow bones. Dinosaurs had feathers. Dinosaurs have, this semilunate carpal, this wrist bone. When we move our wrist goes like this. Mm-hmm. When birds fold their wings, their wing actually goes like
axis, that.
Yeah. And dinosaurs invented that. And so I think dinosaurs invented song, dance, vibrant colors. I think all those things that birds have, I think dinosaurs had first. Steven Spielberg wasn't going to make vibrantly colored feathered dinosaurs because he didn't think they were scary enough. But
it would just be like jarringly outlandish for I feel like the thoughts at the time, right?
But when I have artists make dinosaurs for me, I make them vibrantly colored.
Sure. But back to the warm-blooded thing.
But warm-blooded, yes. So dinosaurs invented warm-bloodedness.
Yeah.
But again, we have this go back to our preconceived ideas. Dinosaurs are reptiles. Reptiles are cold-blooded, period. Mm-hmm. Right? Well, that's not true. Some reptiles are cold-blooded, but some reptiles evolved warm-bloodedness, and dinosaurs were part of that group. And what that warm-bloodedness allows them to do is grow fast.
Huh. So that
when you're talking about that for very long,
16 inches to 9 feet in the first year, you don't think that'd be possible had they been cold-blooded?
They couldn't have done that. No.
Yeah. And what was the scientific?
I mean, look at, a crocodile grows pretty fast. They hatch out of their egg and they double in size the first year.
Mm-hmm.
Double in size. So if they're a foot long when they hatch out, they're 2 feet long by the end of the first year.
Yeah.
Well, if you think about a robin or a meadowlark or something like that, they hatch out of their egg and 2 weeks later they're full grown.
Yeah.
I mean, they just really grow fast, but they're in their nest. They're being fed constantly. They can't walk. They can't expend a lot of energy. They just grow, and they grow really fast. Dinosaurs were in a nest also. Parents brought food to them, and they grew really fast.
Gosh. So, I mean, I never thought of that. Like, because again, this is like the result of me being raised in the Jurassic Park generation.
Well,
but when I think of, a dinosaur hatching, I think of it like an alligator hatching or like sea turtles hatching or something where
that's the way you've been trained.
Yeah, they pop out and they have like some level of autonomy.
There's nothing to suggest that dinosaurs were like that.
Dinosaurs would hang out in the nest and be dependent
or hang out with their parents. I mean, when we find a group of dinosaurs, adults, we find juveniles and adults together in big groups.
Yeah. So like monitored as closely as bear cubs?
Yeah, probably.
Wow.
Yeah.
That's wild to think about. Do you think
it's just like birds, though? Birds take,
Yeah, well, turkey will trail poults. Yeah, for sure.
Whether they're precocial or altricial, whether they're grazing them in a nest or little ducklings following the parent along somewhere. I mean, they're good parents. And dinosaurs would have been the same. Some of them would have been raising their babies in a nest, and some of them were probably precocial, just like ducks, and went walking, with the babies. Long-necked sauropods, I hope they didn't do that because the babies would have been so tiny compared to the adults that they'd have just squished them.
Yeah. Well, there's sauropods around. I guess that didn't happen all too often.
That's right. I guess they stayed in the nest at least for a while.
And there was a whole bunch of controversy surrounding that, though. People didn't want to accept
hated that idea because they had the preconceived idea that reptiles are cold-blooded, period.
Do you think that has to do with what we were talking about earlier, the cuteness factor and stuff, where they just didn't want to, like, kind of like how...
well, people didn't know. Back then, they didn't know that babies were cute. They didn't know that they had different... Well, remember, people didn't know about the actual ontogeny of dinosaurs until, recently, because babies are so rare.
It was accepted for a long time that there were 12 main species of dinosaurs in North America.
No, that's no.
No, that's... We're in the Northern Hemisphere?
No, that's...
I remember 12. I'm trying to get it to 12, knocking down to 7.
You've got some good data there.
Okay.
You just don't have quite enough of it.
I thought I swear to God, I took it from your TED Talk.
I know you did take it from my TED Talk, but my TED Talk was about the Hell Creek Formation. It was about 68 million to 66 million years ago in Western North America.
Okay.
That's all it was about. So 12 species, 12 primary. There's more species than that, but 12 primary ones.
When I was watching it, I thought to myself, I was like, God, I swear to God, the dinosaur books were more involved than that. Okay, so in the Hell Creek Formation, 12 primary species.
Yeah, and we were able to knock it back, to 7.
Yeah, and is it widely accepted that it's 7 now?
No, obviously it's controversial. I mean,
it's still controversial.
Well, I mean, it's
Your TED Talk was very convincing.
Well, thank you. But, some of the people that named some of those species are still around and they don't like the idea of their species being sunk.
You ever correspond with those folks?
Well, sort of. Yeah. One of them is this guy named Bob Bacher, and he was one of the people that Michael Crichton used with me to make the Alan Grant character, right? So he and I disagree on quite a few things, like T-Rex is a predator or a scavenger, and how many species of pachycephalosaurs there are, because he named Dracorex.
Mm-hmm.
So he likes that one, but I know for sure that Dracorex is at least a juvenile of something. Mm-hmm. It is a juvenile. There's no question about that. So originally there was Dracorex, Stygimoloch, and Pachycephalosaurus.
Mm-hmm.
They were all thought to be related, but different species. And my friend Mark Goodwin and I, we wrote a paper saying that they're all the same species, that they're just different growth stages.
Yeah.
And we still think that. I mean, we have really good evidence for it. But the people that name things like, Dr. Bucker, he likes his Dracorex and thinks it's an adult and that it's going to grow up without a dome. And I say, that's just not going to happen. It's a juvenile.
Yeah.
Another one is, the most controversial one is Triceratops and Taurosaurus. I'll tell you, I cannot tell you why that's
watching your presentation on it, where one of your graduate students, am I getting this right?
John Scannella. Yeah.
He found a depression in that, what do you call it? The fringe?
The frill. Yeah.
In the frill. He found a depression in the frill that looked like it was going to evolve, or not evolve, but progress into like the characteristic holes in the frill of the Taurosaurus. Yep. And still people are like,
Well, yeah. All right. Yeah, if it's got a hole, it's got to be a different species.
But you're like, here's the hole forming right here.
Right, exactly. Yep.
And they just couldn't.
No, that's still. And what's weird to me is,
what's the counter argument to that?
The Pachycephalosaur thing seems way more drastic to me.
Right, the horns reducing on the back and the knobs and the dome.
And it seems a lot more and nobody argues with that as much as they do with the Triceratops Taurosaurus thing, because
I always thought like the Pachyosaur
so weird,
kind of looked like Larry David.
Oh, they kind of do, yeah.
What is the counterpoint to? You're saying, hey, look, we have this really good evidence. Here's this feature starting to become more prominent, and when we bisect these bones or take this this piece from the bone and we look at it, we can tell that this dinosaur has some growing to do.
Yep.
And this Taurosaur, it's Taurosaur, right? Mm-hmm. The dinosaur names are really tough for me.
That's okay.
The Taurosaur, well, we see that it's not only bigger, but if we analyze the bone structure, it's not like an exceptionally sized thing. It's a mature thing. And here are the holes, and there are the holes developing.
Yep.
And people say what to that? They go, well, no, you're wrong because I don't like it, or do they have?
Yeah, they don't really. Yeah.
Well, do they have a counterpoint?
They're just like, I don't believe it. Yeah. It's non-science. It's a non-scientific argument. No one has falsified the hypothesis. No one's ever falsified the hypothesis. They just don't like it, which is just poor science. It's just poor science,
Well, it's what separates.
Right.
It's what separates science from faith.
Exactly. Yeah. No. So it doesn't make any sense, and so. We just keep digging up dinosaurs, and we don't find anything that contradicts it. If we did, though, we would certainly say so.
Yeah.
Everybody's like, well, you just sweep that under the rug, and I'm like, no, actually, that's sort of the creationist thing, right?
Yeah.
The creationists think that we have very good evidence that evolution didn't happen, and I say, I'm as egotistical as anyone else. If I could prove that evolution wasn't real,
I'd be trying to do it.
I'd be the most famous scientist that ever lived on Earth, right?
I'd love to prove that, yeah.
I can't, but, so, I think ego is, one of the proofs of evolution.
Like that. So we've talked about a bunch of, you're somebody that courts controversy, intentional or otherwise.
That's what they say.
People are sort of fascinated about your personal life too.
I have no doubt.
Do you mind if we talk about it?
Not at all.
You grew up in Montana.
I did.
You went to MSU.
I went to
Oh, you went to...
I actually, when I graduated from high school in 1964 and went to college in Missoula, it was called Montana State University.
So I'm only half wrong because I meant the MSU in Bozeman.
Yes, you're only half wrong. It switched its name in 1965 to the University of Montana. Bozeman was at that time in 64 called Montana State College.
Okay.
And then it took Montana State University's name.
Gotcha. I understand. And actually, before we get to this, I do want to talk real quickly. You had a kind of interesting detour in the Vietnam era.
I did.
Wait, what happened?
I got drafted.
Yeah.
I flunked out of college.
Well, you got drafted and then you kind of got put into a crazy spot. And I don't think a lot of people, because I didn't know this about you until, I don't even think it's in your like Wikipedia. Like I think I read it on some little like fact-findy website. So you got drafted?
I flunked out of college. You know, I flunked out of college 7 times. So, you know.
You're dyslexic.
I'm dyslexic,
Yeah.
Anyway, I flunked out of college and then got drafted, and I thought I was going to be drafted into the Army like everybody else, but the Marines were drafting at the time, and I got drafted into the United States Marine Corps. Mm-hmm. But I was, I was a scuba diver. I was when I was in college flunking out. I loved swimming, and I learned scuba diving, and I got my NAUI instructor thing. So I was a good scuba diver, and I could teach scuba diving. And so when I was drafted, they figured, I guess, that all they had to do is throw me out of an airplane, and then I'd be a Special Forces Marine.
Yeah, so you're Special Forces?
So they stuck me in recon, and I was a reconnaissance Marine.
Did you ever end up going over to Vietnam? Or
yeah. Oh, yeah. I spent almost 14 months there.
Yeah.
Being a recon Marine. Yeah.
That's that's like a shockingly different environment than Montana. And I know that we have some other stuff to talk about, but I'm very interested in this.
What was interesting to me for the Marines was, I felt sorry for a lot of the inductees, the people coming in, even the people that had volunteered, because a lot of them came in and they were not in very good physical condition. Oh. And I was a Montana guy, and I was in very good physical condition, but mentally they break you down to zero, and then build you back up into a mean, lean fighting machine, right?
Yeah, sure.
But other than that, I mean, the physical stuff was not hard for me at all.
Yeah.
Running and jogging and
you'd watch these other dudes just
and shooting,
eating it.
We grew up in Montana. We know how to shoot a gun. So, I mean, that was easy. And hand-to-hand combat, we're always, I had a brother I was beating up all the time. So So,
my little brother's bigger than I am, so I can't quite relate to that. But we fought.
I did get to the point where where he did get bigger, and so
yeah.
But anyway, Vietnam was Vietnam. I mean, it was
sure.
I learned a lot about a lot of things, and there were combat situations, and mostly I was a forward observer. Mm-hmm. So I was out in the countryside by myself a lot, which was a lot of fun.
Yeah.
But, and got to meet people, and even met North Vietnamese who I got to know that were North Vietnamese kids trying to get to the United States. They were studying English and American history, asking me where I was from. I mean, and knew that Helena was the capital of Montana.
Really?
Yeah. It was amazing, a lot of people, the people wanted us there. It's pretty hard, when you get back, when we came back, all of us, when we come back to landed in California and people were throwing bricks at us.
Protesting and spitting on folks.
Yep. It was hard to come back. It was bad enough to be in a war, but then come back and have your own people throwing shit at you.
That's the first time that had really happened in American history, up until then. You came back and you were heroes.
Yep.
Did you expect that when you were coming back, or was that shocking to you?
It was shocking.
Yeah.
We heard, we knew there were protests going on.
But you thought, oh, that's just somewhere else.
Yeah. But no, it wasn't somewhere else.
Gosh.
And, went back to my hometown and, nobody asked me about my experience in Vietnam until this year. At Chapman University, where I teach, one of the professors taught a class on Vietnam this year, and she asked me to come in and tell the students about what it was like being in Vietnam.
You'd never had anybody.
First time ever in my entire life that people asked about and wanted to know what it was like. Yep. Isn't that something? Wow.
After all that time, having not like erased it from your memory, but having it be like, okay, well, that's like something that happened and not something that I'm, talking about a whole bunch, either prompted or otherwise.
I wrote a little essay about it one time, about a firefight I was in. And, it really didn't get much reaction. I mean, I don't think most people know how to even talk about it.
Other than your experience coming home, what was the primary thing that you took away from Vietnam?
Just the whole business, it's like the protests. I mean, people were protesting us being there. And yet when you're there, the people are just so happy that we're there helping them. I mean, it wasn't like it wasn't like the locals didn't want us there. They wanted us there, and they were appreciative that we were there helping. So, you see both sides, right?
Why do you think that nobody had asked about Vietnam? Do you think it's just because your career overshadowed personal experience, or do you think it's a? I don't think any Vietnam veteran was asked very much about what their experience. I've never met anyone that every Vietnam veteran I've ever met has always said the same thing. Nobody wanted to talk about it. It seems like Vietnam is like it's like a really dark thing, and maybe it's a lot like when you see a lot of World War II discussions and documentaries and speakers and all that stuff. Where most of them from? It's like they talk about Bastogne, they talk about the Battle of the Bulge, they talk about the European theater. Less so you hear about the Pacific theater and places like Iwo Jima and Okinawa. And to me, I feel like leading up to that, with both the guerrilla, I guess, sort of nature of like the conflicts and the brutality of the conflicts.
Yep.
Vietnam is a way closer proxy to the Pacific theater in World War II than it is to a lot of the other stuff. I mean, I feel like Vietnam kind of set the precedent to have there was pre and post Vietnam, and war changed drastically in between. I mean, war is awful regardless of what medium it takes, for sure. But there's a certain sort of discomfort that comes with talking about those just really, really raw, immediate experiences.
Yeah. When I got my job at Princeton and went there, one of my colleagues there was one of the protesters, and somebody that would, and I kept telling him, you only know half the story. You have half the story. You have no idea. Nobody really knew why we were there other than to help the South Vietnamese, defend their country against the invading Chinese, basically, right?
Yeah.
Our country is so isolated from every other country that we don't really have that personal interface with anyone. People coming up to us and say, "Please help me."
Yeah.
You know?
It's not like we're in, I mean, we got Canada, we got Mexico.
Yeah.
We don't have like,
Right.
like how tightly Southeast Asia is packed up.
Yeah. No, it's just, so it's easy to protest, we just as well be protesting, helping Ukraine or anyone else.
Sure.
I mean, we're so isolated from those places that, they're just it's something else, right?
How could you have the picture unless you were there?
No.
Did you talk to that colleague about it?
Yeah.
And
I said, you just, I kept saying, I mean, the protesters are supposed to be these, they claim to be, humanitarian, right?
Yeah.
Right. And so you say, well, what would you do if somebody came up and said, please help me out? This bully is beating up on me. Can you help me? Of course we're going to help. We're Americans. And that's what we do.
And what did he say to that?
And, I think he finally came around to understanding that he had half the story.
Yeah. How long, I'm sorry, I know this is tangential, man, but I'm interested.
It took, I don't know, it took quite a while for him.
Did you ever consider him a friend?
Yeah, he's still a good friend.
Really?
Yeah.
That's great.
Yeah. No, we were colleagues, and he comes out in the field usually every summer. And we're good friends. But, he's, like I say, he only had half the story. And once you present the other side to them, they realize that they would do the same thing.
Yeah.
He would not have gone. He'd have probably gone to Canada, right? I lived 30 miles from Canada, and
you didn't go to Canada.
Didn't go to Canada.
No. Well, I guess that's kind of moves into like, the next question, and that being people having half the story about something and making pretty intense judgments on that. Correct me if I'm wrong.
Yeah.
Like, cause when you hear something, like when you get presented with like certain facts, and then sometimes you read too much into them, and you realize what you think is a fact-finding mission is actually your perspective starting to be slanted by an opinionated writer or reporter or something like that. So I tried, I didn't read too much into it, but I know it's something that exists. Your split with MSU and Museum of the Rockies, right?
Yeah.
You retired.
I retired.
I feel as if you might not have wanted to retire at that specific point in time. If there would have been, it was political, and there was, I had done something that some people didn't like very much. Which was what?
Marrying a student.
Huh. Well, not your student though.
She wasn't my student. No,
right.
She was very interested in dinosaurs, and there was a lot of rumors going around, and there was a
prior to you being
lawsuit going on with the university. The museum was having a lawsuit with someone that didn't pay their bill, and so there was a lot of things happening at the same time, and plus, there was rumors going around that I was having these nefarious affairs with students, which were not true, but optically kind of might have looked like that.
Sure.
And lawyers were brought into the university. A lot of people were talking to myself and the student, and we decided that we agreed that one way to fix it was just to get married.
Yeah.
And so we did. And we did it in Las Vegas, and we did it very short order. But her parents came, her father gave her away. It was a beautiful wedding.
Yeah.
It was, and she's still one of my very best friends, and so are her parents. It was not a romantic thing. It was just done to take care of a situation. And it took care of the situation completely.
So,
and if I were presented with the same situation again, I'd do it the same. It worked. But people were just, I mean, it was just shocked.
They just saw like, okay, well, there's these rumors, and here's a marriage with an age gap, and I mean, a significant age gap.
Significant, yes.
You were 65,
and she was 19.
19. Yeah. So, by all, I mean, that's like a rock star age gap. That's when like Mick Jagger.
Yeah. Okay, well, yeah. Like I say, it was fun. It was like I say, it wasn't a romantic thing.
It was a platonic relationship.
Fun. It was really fun.
Yeah,
and we traveled all over the world.
Yeah. What was the relationship purely platonic?
It was platonic. Yes.
Yeah. Okay. But ultimately, you still felt that people were pressuring you or like kind of pushing you around or trying to get you to.
There were some political things going on at the Museum of the Rockies at the time that were just, as you know, if you have a boss and they don't want, they're trying to, they start limiting what you can do, right? And that's what started happening a lot.
Yeah.
I wasn't supposed to go get money. I wasn't supposed to collect any more things. There were just a lot of things, a lot of barriers were put up, and
they were just kind of hamstringing you, and it took the joy out of it.
And I just, I decided I would retire when I was 70. And so I did. But I have a good relationship with Waded at the university and, the president of the university. And after I was married, I still went out and gave lectures for her and did stuff with the university.
Mm-hmm.
And once the people that were limiting my activities at the museum were gone, I work with the museum now, and the curator there who replaced me is one of my former students. In fact, all three of the paleontologists who teach dinosaur paleontology at the Montana State University were my former doctoral students. Well, so I'm pretty proud of that.
And so much so that there is, what is it? It's a $3 million endowment.
Endowment for the John R. Horner Curator of Paleontology. Yes.
And that's wonderful.
That was one of my donors. So, there's nothing nefarious about any of it. I mean, it was a way to solve a problem.
Yeah.
And it worked very well. And like I say,
unorthodox, but it
was definitely unorthodox.
Yeah.
But, that's what I do. Challenge convention.
Yeah. Well,
but, like I say, she's coming out in the field with me this summer. She was out last summer. She's one of my best friends, and her parents still good friends.
So what excites you about paleontology in the modern era? I mean, I'm sure anything paleontology excites you.
I have a lot of former doctoral students, and they've gone on to to become famous paleontologists on their own. And so I get to go out on their digs now. And that's what I'm going to do later today. I'm going to go out on a dinosaur dig that is, the person in charge is one of my former doctoral students.
That's wonderful. So you get to see your legacy working firsthand.
That's right, exactly.
That's got to be really satisfying.
It is. I am so proud of my students. I've had a bunch of them, and including the ex-wife. Right?
Yeah. That would have been a really good note to have ended that on. But I do have some more questions. One of which is, I feel like one of the things about social media is that it can open your interest up to a lot of other folks and make other folks care about the things that you care about, which is good because then you create like advocates for things. However, I think the other thing that happens is like you get a certain amount of folks kind of participating in not super thoughtful ways. Like somebody sees a dig on social media, goes, oh, I kind of know a place that looks like that. They go dig in and they monkey up a lot of stuff, or, they're just not doing the due diligence, and maybe there's research and important information that gets lost in the process. Yeah. How do you feel about, if Jurassic Park was the dino paleontology renaissance, and social media is like a second sort of renaissance for a lot of outdoor activities? How do you feel about that in paleontology? Have you noticed that, or that people are getting out there and just messing around and monkeying around with things kind of thoughtlessly? Or
most people don't know what to look for. I mean, we had a landowner out in the field with us, not, just a few days ago. And, we were excavating a dinosaur on their land, and they were like, wow, I would have never noticed this. It's a dinosaur bone this long. It's a Tyrannosaur bone this long. And they said, well, I just thought it was a rock. So, most people wouldn't know it if they saw it. A lot of times hunters come across fossils and sometimes they just take them home, and sometimes they call us and let us know that they found it. And then we go out and actually collect it.
Yeah.
Sometimes people say, I found a petrified rattlesnake, and I, go out and look, and I'm like, well, it's not a petrified rattlesnake. Sometimes people say, a rancher called me one time and said, I found a dinosaur egg. And I said, well, how big is it? And he says, oh, it's about the size of my tractor tire. And I said, well, that's not a dinosaur. That's probably a concretion, a giant round rock. I said, the biggest dinosaur eggs that we've ever found, and the biggest dinosaur egg we know could even be laid by any dinosaur we've found, is not much larger than a soccer ball. I mean, they're not very big.
Yeah.
And so, I know it's, I can just tell you it's a rock. Mm-hmm. Someone called me one time and they said, we found a beached whale in a lake up near Browning. And I said, oh, no, I'll just come look.
Yeah.
Because I was interested in that area because it's the right area for something. And it was the Bear Paw Shale, which is, basically where your fossil came from.
Yeah.
And it came out there and we were driving along and we were in gravel. We were in Pleistocene gravel. There should have been maybe mammoth elephant bones or something like that where we were. We get to the edge of this lake and look over, and in the water, on the bottom of the lake is a mosasaur, a 30-foot long mosasaur, whole skeleton all together, beautiful thing, underwater, laying on the bottom of in the Bear Paw Shale. It was, the animal that eats these kinds of things, a beautiful skeleton. I was like, I almost fell off the cliff. I mean, I was like, whoa, that is really cool. I said, I don't know how we're going to dig it out. I don't know how we're going to get it out of the lake. But
what happened?
Well, we built a fence around the thing. It was in about 3 feet of water. And we built a fence around it and then put canvas down on it, and then got a sump pump and pumped the water out. Oh. And we collected it. It was in October. It was cold. It was nasty. But we got it. It's in the Museum of the Rockies. It's not on display yet, but it's collected. But it was just shocking to see it. I mean, it was one of the best skeletons I've ever seen.
It's amazing.
In the water. I mean, but sometimes things are real and some things are not. And some people, want us to collect it and save it in the museum. Some people want to sell it on eBay. I mean, when fossils are found on private land, the private land owner owns it,
fossil,
and they can do whatever they want with it. Yeah. So some people donate it to the museum. Museums don't buy fossils. We don't sell fossils. We just try to save them for people to see.
So, okay, that's a pretty good segue into, we mentioned that sometimes hunters find fossils, and as a hunter, I found a fossil.
You did.
I know what I did with this. I put it in my pocket and I took it home because I was pretty confident that it wasn't from a vertebrate.
Right.
Because you can't take.
You're not supposed to. No.
Anything.
You're not supposed to. No,
but invertebrates
are fine. Yep.
Fair game.
Yep.
Okay. So I found this on public land, took it home, and it is, what is it?
It is a chamber from an animal like a chambered nautilus called an ammonite.
Yeah.
And the Native Americans used to collect them, and they called them buffalo stones. And they'd put them in there, usually from smaller individuals, but they'd put them in their medicine bag.
Very cool. What do you recommend that one does when they find something that they think is a fossil, particularly a vertebrate fossil? Because I'm sure it's not, tell your buddy, hey man, let's put this in our
bring
pocket.
it to the museum and ask.
Yeah?
Yeah.
Yeah. Not leave it in place. And
well, it depends on what you find. I mean,
sure.
There was a rancher down in central Montana, near the town of Winnett. I don't know if hardly anyone knows where Winnett is, but Petroleum County, found a specimen, asked someone to, one of our colleagues to go out and check it out. And it was a Taurosaurus, a tauromorph Triceratops skull, half of it showing, the whole thing 9 feet long.
Really?
In the side of a cliff. It was just incredible. And it was on private land, and we asked the private landowners if they would donate it to the Museum of the Rockies so we could excavate it. And we excavated it. We made almost a cave to get it out because it was a really high cliff and really hard sandstone. And then we talked the Montana National Guard into sending a Black Hawk helicopter out to lift it out of the ground. It was gigantic.
That's unbelievable. Is it hard to convince people sometimes to donate the fossils that are on their property?
Yeah, because a lot of people think they're worth millions of dollars, and sometimes they are worth millions of dollars, but they're worth millions of dollars after they've been excavated, prepared for exhibit.
So part of your argument
most of the money, hardly any of the money goes to the rancher or the landowner. It goes mostly to the people that actually do all the work.
So part of your argument is, one, you don't even know how to get this thing out of here.
Right.
And two, it's even if you did know how to get it out of there, it would be so costly that by the time you sold it, you wouldn't make that much money anyhow.
Exactly.
So why don't we just get it out for free and you give it to us and you come visit it where it might.
And you can, get a tax write-off for donating it.
Oh yeah? Huh.
That, if your ranch or farm actually makes money, right?
Yeah. Yeah. I want to ask you so many more things. We don't have that kind of time though. You got to get out to your dig.
Yeah.
But if you wouldn't mind, do you think I could get you to listen or to answer some listener questions?
Of course.
Okay, cool. These questions, by the way, are sourced from Instagram. You can find me at Hayden_Samak. All the time I'm posting stuff. Hey, I need questions about this. I need questions about this in relation to our guests. So if you want to ask a question, follow me. Look out for those question call to actions and submit questions because we try and answer as many of them as we can. You guys are pretty darn good at asking good questions. And with that, we're going to get to some of those good questions. We're going to flip on the Andy cam. That's what we call this camera right here that points ominously at Andrew. And Andrew's going to read some of the Instagram sourced questions.
Yes, sir. Mr. Horner, I have a question from Ryan Ebert's art. When illustrating them, how do paleontologists guess things like skin, texture, color, or feathers?
Good question. Well, fortunately, a lot of times dinosaurs died in environments that actually preserved the texture. And so just like a footprint, just like when we walk on the sand or in the mud, we leave a footprint, and then another, sand or mud fills in that and preserves the footprint. When an animal dies, oftentimes they lay down they end up laying in that mud and leave the impression of their skin, which gives you the texture. So we have skin impressions of quite a few dinosaurs.
Thank you, Siri.
And sometimes those impressions are actually feathers. And so we do get feathers preserved, and we get skin impressions. We don't know what color they were, but, dinosaurs gave rise to birds. Birds are colorful, vibrantly colored. Mammals are not, because mammals evolved as nocturnal creatures, and so most mammals are colorblind, and most mammals actually communicate with pheromones rather than visually. And so birds and other reptiles are very visual and therefore probably all very colorful.
Craig the Tripper asks, what are some of the evolutionary holdouts from dinosaurs that are still visible in game birds?
Well, that's a...
I guess he means like turkeys, sharp-tailed grouse.
Yeah, they're really, I'm not sure what he means by a evolutionary holdout, but we can make we do occasionally find evidence that some dinosaurs had a comb-like structure on their heads, like turkeys or chickens. We do, dinosaurs, like I say, gave rise to birds, and birds, for a long time, we thought birds, had specific characteristics like hollow bones and feathers. We know dinosaurs had those first. And so basically almost every feature that birds have is an evolutionary holdout from a dinosaur. I mean, how we separate avian dinosaurs from non-avian dinosaurs is basically by the flight feather. If they're a avian dinosaur and they could fly, we'll call them a bird. If they have feathers, but they're not flight feathers, we might call them a non-avian dinosaur. Yeah, it's hard. Birds really are dinosaurs. They're a group of dinosaurs.
So what you're saying is a bird is an evolutionary holdout of a dinosaur.
Well, yeah. I don't know if evolutionary holdout is the way to put it.
Yeah, I guess he means like a vestigial trait. I think that's what he's kind of getting at.
Basically, all of their traits are, derived from non-avian dinosaurs.
Okay.
Eric Hover asks, which dinosaur had the loudest roar?
Dinosaurs didn't roar. Dinosaurs, birds, our larynx and our sound box is very different than a reptile or a bird. And so we produce sound differently. And so it's, crocodilians will make grunting sounds. They don't really make growling sounds like lions or anything. So dinosaurs, probably made sounds more like crocodiles and birds. I think dinosaurs probably could make deep singing sounds like birds do. So if you go, those of you who've never been to the Museum of the Rockies might, when you go into the museum's dinosaur hall, you will hear sounds, and those sounds are actually bird songs that have been recorded and then slowed down.
Huh.
So they are real dinosaur sounds.
Yeah.
Because birds are dinosaurs.
Brent Flack asks, what kind of dinosaur is Barney? He can't be a T-Rex with those big ass arms.
Many years ago, I was called by a lawyer in New York City and asked to be a expert witness in a trial where the creators of Barney were trying to convince a court that Barney was not a dinosaur because if it was a dinosaur, then it couldn't be trademarked. So they were trying to retain the trademark for Barney. So they wanted an expert to come and say that Barney was not a real dinosaur.
Well, I feel like I
declined.
I feel as if the song, the opening line to the Barney theme song is "Barney is a dinosaur."
Okay,
that's so funny.
Next,
what happened? Well, hold on a second. Before we move on, what do you know? What happened?
I have no idea what happened. I declined. I didn't want to get in the middle of that for sure. I have enough controversy in my life.
Jurassic Park was cooler, man.
That's right.
Okay. Adaptive Outdoorsman asks, what was the average amount of calories needed to sustain a brontosaurus?
That's a really good question. We don't actually know. But as I was saying before, birds are dinosaurs. Dinosaurs invented a lot of the characteristics that that avians have. And one of the interesting things about birds, and we know is true about dinosaurs, is they have a breathing system that is highly efficient. When we breathe in, we take in air to our lungs and then we breathe it back out again. So it goes in and out, and all of the air that's in our neck is basically dead air, right? And so a sauropod, between its head and its lungs, there's a huge dead air space if it were breathing like us, but they're breathing like birds, which means air goes in through their lung, completely through their lungs into air sacs in the bones. And then when they're breathing in, air is going through their lungs, and when they're breathing out, air is going through their lungs. They have fresh air in their lungs all the time. That's what allows birds to fly. That's why they're so efficient. Otherwise, if they had lungs like us, they'd be flying along pretty well, and then they'd fly well, and it would not be good. But dinosaurs are the same thing, and so they have these huge air sacs, which means dinosaurs were a lot lighter built than you would think when you look at them, because they have all these hollow bones and hollow air spaces in them. Plus the fact that their digestive system is also much more efficient than ours. Think about a cow, right? They eat grass, they chew it, they swallow it. It goes through the first stomach. They regurgitate it. They chew it. We call it chewing the cud. And they chew it again. They swallow it again. It goes through a couple more stomachs, comes out the back. You can tell they ate grass. A bird, no matter what it eats it. It goes through the system very quickly, and it comes out a white spot. Dinosaurs were the same. So their digestive system, much more efficient. And so, you think about birds. Birds sit on the wire. Their digestive system, breathing system, all much more effective than ours. Birds sitting on a wire watching the cow eat, like, whoa, he just eats all day. Oh, boy, let's go play. And the dinosaurs would have been the same. They're, yes, they're gigantic, but they probably didn't need anywhere near as much feeding time as
big ungulates.
As the big ungulates, yeah. So I don't know what the calorie intake would be, but I can tell you that we shouldn't be comparing it to mammals.
Man Like Ape asks, what was the function of the plates along the Stegosaurus's back?
Good question. People have, it's controversial, I can tell you. Some people think that they were some kind of heating device or cooling device or something having to do with their physiology. But the closest relative to a Stegosaurus is a thing called Kentrosaurus, and it has spikes instead of plates, which suggests that it's not for heating and cooling, because if the physiology of one animal needed it and its closest relative didn't, that would be really unusual. And so we can see that the plates were actually covered with keratin, and keratin could be very colorful because we see on birds, keratin-covered structures are very colorful. It's more than likely for display, whether it's sexual display, different colors for male and female, or some kind of visual cue for mating, who knows, but it is most likely for display, as is the horns, the shields, the spikes, the domes, everything else that we see on the heads of dinosaurs.
So that Triceratops.
Right. They did not go around stabbing T-Rexes.
Yeah.
It's all display. It's all display features.
Yeah. Because, what I've always equated the Triceratops frill to is the same way like elephants cool down.
Yeah, that doesn't. Yeah, it
doesn't translate.
Doesn't because it might work for Triceratops, but all the other horned dinosaurs have giant holes in them. I mean, they're basically just skin structures they're like this frame for a skin, and it all display just makes much more sense. And you think about antlered animals or horned animals. I mean, it's sexual dimorphism, sexual display. I mean, there's all sorts, but deer and elk do not go around stabbing, coyotes, or they'd have them hanging in their antlers all the time, right?
Yep.
Matanuska Jim was curious about the idea that dinosaurs might have been warm-blooded, but we've covered that.
Yeah, we hit on that pretty good.
Dinosaurs were warm-blooded.
You hear that?
But of course, it's controversial. Of course, some people think, well, maybe they weren't, but we have really good evidence.
Yeah,
just even looking at growth rates.
Yeah, that's my buddy Jim Majetic. He found out that I was talking to you. He's like, "Look, man, I'm a closet dinosaur nerd, and I got some questions." So I was like, "Okay, well, I'll try and work that in."
Dinosaurs were warm-blooded.
Yeah,
dinosaurs were warm-blooded.
Well, on that note, do you got something, Andrew?
I've got a question, and you can tell me if these are stupid, but because atavistic genes were evolved in a high oxygen environment, how might you expect the features or manifestations of an activated atavistic gene to be impacted by our lower oxygen atmospheric content?
See, I told you he was the smart one.
This might be a really dumb question.
Well, I
sounded smart.
So you've mixed two things together. Atavistic genes are just ancestral genes. I don't know what that has to do with oxygen.
So let's say dino chicken becomes a real thing, and it starts manifesting these kind of ancestral features that were evolved in a really high oxygen atmosphere. In a low oxygen atmosphere, when they make their manifestation, would it have any weird?
The difference in oxygen between
it's not relevant.
65 million years and now is irrelevant.
Okay.
Was there a significant difference in oxygen?
No. But there's a temperature, there's a oxygen gradient through remember, dinosaurs were on Earth 155 million years. And so T-Rex to Brontosaurus, right? The time is greater than the time between T-Rex and now, right? So T-Rex is closer in time to us than T-Rex is to Brontosaurus. And so oxygen levels may have been higher or lower. I don't even know which one. back in the Brontosaurus days. But like I say, their breathing is much more efficient. So I don't even know that it would make any difference.
Mm-hmm. It might have been a misconception on my part, but I thought that part of the reason dinosaurs were so big was because of the higher oxygen content.
Yeah, that was an idea that people had, but I don't.
Okay.
I don't think there's any
merit.
They just really had a much more efficient system.
Mm.
One last question. Once atavistic genes have been turned on, would they stay on in their offspring?
We don't know. Actually, if we make dino chickens, we're just going to make them one at a time. We do it in one egg. We're not changing DNA. So if a dino chicken mates with a chicken, they're going to have more chickens. We have, a dino chicken, to make a dino chicken, we literally go into an egg and switch the genes off or on. One egg at a time.
I just want to thank you so much
for
coming on today. And if you guys want more of Jack Horner, we're going to put a lot of his links down in our show notes here, so you'll be able to follow along with him, what he's doing, as well as some additional resources, past TED Talks, things like that. Thank you, Jack. Thank you very much to our engineer and co-producer, Andrew O'Neill. And thank you guys for listening. Remember, subscribe, follow along with us here, and we have some really great stuff coming out in the very near future. And see us back here next week. Hey everybody, thanks for watching this episode of the Backcountry Manifesto podcast. If you want more Backcountry Manifesto, go ahead and check out one of these links right here. And make sure to share the podcast with your friends, comment, like, subscribe, do all that good stuff. It really helps us out. Again, thank you very much for watching. Now go check out one of these things. I like this one. This one was a good episode, I promise.